Hey, stat students, welcome back to Dr. Centers. Today we are going to review Chapter 5. Last week we worked on the 5 steps of hypothesis testing and looking at one individual, and we were walking them through those 5 steps, whether or not to reject or retain the null hypothesis. So if you remember last week, we were comparing one person, if they maybe won the lottery or not, or looking at one person and their one person's stress level and compared it to the population in regards to their stress. That was a great kind of helped give us direction of how hypothesis testing works. But in reality, when you're doing research, you'll never just really focus on one person. It's very, very rare. In unique circumstances, you may do what we call a case study with one person, but the vast majority of research and statistical analysis is we have to use a group of people, which we call a sample of individuals to help get that information. For example, if we are interested in the stress level of college students right now, so we are interested in all of South Mountain Community College students, okay? So maybe there's 6,000 students currently taking classes at South Mountain Community College, and I wanted to ask them their average stress level. It would be very difficult for me as a researcher to go to every single person, email them, call them to go to every single class and get their stress rating, okay? It's not very practical. It takes a lot of time and money. So what researchers do, instead of researching all 6,000 students, what they will do is they'll take what we call a sample. A sample is a subset, a small group. So on average, a sample, we want it to be at least 30 people, okay? A sample size should be at least 30 in order to have a normal distribution that we're trying to get. But that 30 people is what we're trying to get that information from. So for example, if I want to know the stress rating, maybe I'll ask some students from our class that we're in right now, or maybe ask them from an English class or a biology class and get a kind of a well-rounded sample, a random sample, so to speak, of our student body. And then what we're going to do is once you have a sample of people, then you can make decisions about whatever variable you're working with and apply it to the population. For example, again, right now there's a bunch of research going on for the different vaccines for COVID. They are doing these large scale studies of 100,000 or some studies of 40,000 participants, and they're looking at the efficacy of the vaccine. Does it produce antibodies? Okay. Now, what they're doing is trying to get a big sample to say, what is the efficacy? Because then they are going to distribute it to all Americans or all people in the world. And it's not possible for you, me, and everyone in the world to take part in this study, but they need a large sample to do it. So they take the data, the information from the sample, and then apply it to the population. Okay. So you take the information from the sample and apply it to the population. So in chapter 4, we were focusing on one person, but now as we move forward in the class, from here on out, we're going to assume that we're looking at a sample. A sample is a group, again, the group of people that are, and we're getting that data. So we're talking about at least 30 people. So this is kind of what we're focusing in on for the rest of class. So chapter 5 gets very, in your book, it gets very focused in on the steps of how to do that. Good news is you're not going to have to do those mathematical steps. I'm going to show you a couple things of how to use it in PSPP today and some of the Cliff Note versions that you'll need to know as we move forward. So what in this chapter they call it is hypothesis testing with the means of samples. So we're going to be working with the means of samples. So when we're talking about a sample, we want to get the mean and standard deviation. And it's a comparison distribution considered so far where a distribution of individuals. But now hypothesis testing involves means of groups of scores. So the comparison distribution will be the distribution of means. I know that sounds very wordy, but let me show you here visually what that looks like. So taking a look here, we have A, B, and C. Okay, the first one, A, is the distribution of the population of individuals. So this is a normal curve, okay? What we looked at, it's a normal bell-shaped curve. what this is looking at is it's taking every individual, student 1, what their stress score, student 2, what's their stress score, what's student 3, and say on average, the mean, and maybe in the middle, the average stress score is a 4. Then we have some people over here with a 3, over here with a 6. And then you have in the extreme scores, you have 8s and 9s and maybe 0s and 1s over on this end. So you have a normal curve of a distribution, okay? In actuality, how we get our distribution is we don't necessarily work with the distribution of individuals. We'll move over here to letter C, which is the distribution of means. And how you get the distribution of means is through what we call a particular sample here. So what this is assuming is letter B is taking, what you'll do is saying, I want to get the average scores of a stress rating. So I get our class. I get all your stress levels and I get the average of that one. So I get our class's average and then put it in here. Then I get a biology class's average scores and put it in there. Then I get a math class and then a reading class and put it in. So I'm getting all these different scores. But what's happening is I'm taking the sample score, the average score, and putting it into the distribution. And if you take a look here, if you compare between A and C, letter C is still a curve, but if you notice, it's much more skinny, okay? The reason it's so skinny is because when you have the distribution of means, because you are taking samples, it's averaging out all of the extreme scores. So for example, if we have our class and we're stressed out, okay? We're taking stats online, we're having to do a lot of homework. So our stress is like, we have a couple people with tens, but then you have other people in the class, maybe you have a 4 or a 3. So what happens is when you get a 10, a 4, a 3, a 6, what happens is the scores start to come more condensed. So the average is maybe a 5, okay? So when you average scores, it tends to take away some of those extreme scores. So it doesn't go as far over to either side on letter C as letter A because we are not dealing with those extreme scores anymore. So it tends to be tighter when we're dealing with the distribution of means. In your book, it kind of compares the differences between the equations that you're going to work with. If you see this in your book, just to make yourself aware, the mean, this is mu, okay? When we're working with the distribution of means, what we'll be working with from then on out, we are assuming that we're working with distribution of means when we're doing this type of research. It's still the mean, but you'll see a little m underneath it, and that underscores that it's the mean of the distribution of means, okay? Variance is the variance of, with an m, with the distribution of means, okay? And how it finds the distribution is it divides by n. It's the very same formula here. And then the standard deviation is the standard deviation of the distribution of means. So what you need to know here is that we assume the shape to be normal is if there's at least 30 people in a sample. So we want to make sure there's about 30 people there. All right. And the other aspect of chapter 5 that you're going to be this is kind of some working knowledge for you to have, is you're going to have to do what we call confidence intervals, okay? It's an advanced topic, but it's a confidence intervals, and there's 2 types of confidence intervals, 99% confidence intervals and 99%, 95 and 99% confidence intervals. There are several steps to do that, but what we're going to do is I'm going to show you how it works, okay? So confidence intervals, the basis is it's creating a spread of numbers, a lower limit and an upper limit. It's creating a range of scores where the population mean can reside. So because in most cases, we do not know the population mean. So for example, I'm interested to know what the average amount of dollars that a college student has in their possession. So how much money you have in your wallet, your purse, your car, not in the bank. Some of you guys are like, I got nothing. All right, me too. Or some of you, okay, we have $100, $50, $3, 42 cents, whatever it is. And we're interested, okay, what does the average student have? And what confidence intervals does is it gives us a range of scores where we can be a certain percent confident that if we were going to do this study again, we would find that solution. So let me show you an example here. So this is just a confidence interval, how it works. So this is the 95% confidence interval. Say, for example, I'm looking at, maybe I asked a bunch of 5-year-olds, how much money do they have at their house? Okay, all right, in their room. All right. And we found the average 5-year-old has $4.27. Okay. We know there's a range though. Some people maybe got a big allowance and they got $8, maybe, but then some, have nothing. Okay. So what confidence intervals do is they do the distribution and they find the percentage of the limits. So there's always a lower limit. So on average, there's $2.92, and then the upper limit is $5.62. What that is telling us is that we're 95% confident that with a 5-year, that we're 95% confident that the average 5-year-old will have an average of $2.92 and $5.62 in their bank or in their room. So what it's doing is telling us what percent confident we are that they have this amount of money. So it gives us a range. So it gives more information than just the mean. It gives us a spread or a range, okay? Now, if we were doing 99% confidence interval, it actually would get a little bit larger. So our lines, because our percents here, if it's 99%, this would only be 0.5%, so it'd be out here, and then 0.5%, so it'd be further out. So it'd be a little bit further spread out. So our lower limit may be $3 and our upper limit may be $6. So the spread is bigger as you go up in confidence intervals. In your in the class today, we are going to you're going to work with a data set. Okay, if you open the data set, you're going to notice that there are pre-populated variables that you're going to get to work with. And then there are, if you go to the data view, you can kind of view them from here. All right. So for example, if we are interested, say I need to find, I have a problem for us to look at. Say, for example, this is the problem. It says this, it says, it is known that the average community college student travels an average of 10 minutes to their college campus. However, at South Mountain Community College, it's predicted that South Mountain students travels farther to get to campus. Use data set 1. So I'm going to do an abbreviated version of the 5 steps. So we have population 1 is our South Mountain Community College students. That's who we're testing, right? And then population 2, all other college students. Now, what is our hypothesis? It's predicted that South Mountain students travels farther. So we could say population 1 travel time will be higher than population 2 travel time. Okay. And then the null is just the opposite. Right. Now, the way you're going to do that, I'm not going to, don't need to worry about step 2, 3, and 4, but how you're going to do this is you're going to compute the confidence intervals. So I need to find the 95% confidence intervals for my students. Okay, I'm interested in finding the 95% confidence intervals. So if I take a look, I have a variable here. It's called commute time. And how you go ahead and view this is very simple. You're just going to go to Analyze. You don't need to have this highlighted. You're going to go to Analyze, Descriptives, and then Explore. Okay. So, and then what you're going to do, reset it here, is you're going to find your variable. So we're going to say total commute time. That's what we're looking for up on the dependent list. I'm going to click statistics and I'm going to make sure my descriptives are selected. Okay. And click continue. And then all I have to do is click OK. And then it's going to populate a bunch of different descriptives about my commute time. First off, it looks at the average commute time for students is 18.77 minutes. Okay. And look, it gives us our 95% confidence interval. This is what we're looking for, 95%. Also gives our median, our standard deviation, our variance, min, max, all those things. So we know the mean is 18.77. I'm going to write that down. Is the mean. And then my lower is 15.01 and my upper is 22.53. Okay. So I head over to my spreadsheet, my sheet again. So my 95% confidence intervals are 15.01 to 22.53. Okay. This is important. So this is what we're looking for. These are our confidence intervals. So what this is telling us, this is telling us that we are 95% confident that the average, that South Mountain Community College students average travel time is between 15.01 and 22.53. So this is telling us that we are 95% confident. If I was going to do this study again, if I was going to do another 50 kids, 50 students, that their average time would be between 15 and 22.53 minutes. Okay. And so one other benefit you can do is you can decide whether or not to reject or retain the null hypothesis. So step 5, I kind of wrote this out for you. It said, if the population mean is outside of the 95% confidence interval, you reject the null. So we know our confidence intervals is between 15 and 22.53. And the average, we found the average, it says the average community cell is 10 minutes, okay? Now, is 10 minutes the population mean outside of this range? Yes. So, since population mean is outside of 95% CI, I reject my null, showing support that SMCC students travel farther than other college students. So this is providing a range, and this is the general conclusion that you're trying to get here. So that kind of summarizes what we're going to be doing for this week. As you get going, this week's focus is solely using the data set that I have provided. I just showed it to you here. You're going to have to run some descriptive analysis. We've done this before. You're going to just run some descriptives of this information. So just a reminder, as you're getting used to these data analysis, when it's asking the mean and the standard deviation, you're going to use your analyze and descriptives, and you're going to use the frequency tab or the descriptive tabs. And then when you have to find the confidence intervals, you're going to need to use the explore. So you're going to be using analyze, descriptives, and these ones here, these 3 tabs to go ahead and answer those questions. And then for one of them, you're going to be doing the confidence intervals, and I need to know whether or not you're going to reject or retain the null hypothesis there. All right, that will do us for chapter 5. Reach out with any questions and we'll continue on. Thank you.